Alright, go.
Mr. Harrington, you make me so mad. I want to drink 2 pounds gunpowder, 2 bullets, shove it up my butt cheeks, and hit it here from 100 miles. Ah!
I don't get paid enough for this.
This better be extra credit. I mean, high points. Or bring my grade up, or whatever.
What grade?
Exactly. Did you stop?
Okay, here we're gonna demonstrate an exothermic reaction with baking soda and vinegar. Exothermic reactions are those that emit heat, they do not absorb it. So, come on, so we're gonna put about a quarter of this container of vinegar in here. Not vinegar, baking soda, sorry. Yep, okay, just pour a good amount of vinegar in there. See? Really fast, really simple, just like volcanoes. There you go. Here's an exothermic reaction. So we're taking baking soda and vinegar and pouring it on weeds to see what it does. Hypothesis. What do you think's gonna happen? Yuck. Okay, so nothing happened yet. We'll look back later. Okay, here we're gonna do another exothermic reaction. This is Diet Coke and Mentos. Jaden has been our volunteer. Don't try this at home unless you know how to do it and have safety goggles, unlike us, because we're dumb.
Okay, you ready? Oh boy, it's getting really sticky on my hand.
And there you go. That's how you properly prepare a Diet Coke. This is random experiment number 2. This is baking soda with Mentos inside of it, pouring Coke on top of it. Another stupid thing, because we're idiots. Go!
Put the vinegar in it.
There's no vinegar.
Oh.
I'm gonna go find see if there's any vinegar inside.
Am I able to eat it?
We said we'd come back to this, and something actually happened. The solution we made actually ate the rust off the pipe away. This is a heterogeneous mixture, also known as a suspension mixture. When you stir it up,
It mixes together.
it mixes together. And if you let it sit for a little time, or for a little bit, it will eventually settle out.
And Garrett and Josh are going to show you how. While I man the camera. Homogeneous mixture. And then Josh, you can.
This is a homogeneous mixture, and it's also a solution because it mixes evenly all across the mixture.
You can tell it mixes evenly because you can actually see the spoon inside. Josh, would you please test the lemonade?
I will. I got it. I'm thirsty. As you can tell, the whatever you call it did not quench my thirst. That's the back of my throat.
Is it sweet?
Yeah.
I don't think I mixed it all the way.
I was gonna drink it all.
And now it's time to review with Mr. Hicks.
Surprise. Okay. So today we did baking soda and vinegar, which helped with double replacement, or it showed double replacement, and we did the Coca Mentos, which showed exothermic. When we put the Mentos in the soda, exploded and all that jazz. We did acids eating the rust. That wasn't planned, but it worked out pretty well. It corroded the old rust and so. We did homogeneous solution when we mixed the lemonade with the water, the lemonade powder, and made with the water made it lemonade. And then we did solvent plus water, which we had water and sugar.
Solvent is the water.
Oh well. And that's what we did so far today.
And that was review with Mr. Hicks. Okay, so here we're going to demonstrate, we have our solvent, which is water, we have our solute, which is sugar, and a solvent dissolves a solute, and the solute is dissolved by the solvent. So when we put the sugar in here, it's going to slowly dissolve. So Josh, go ahead and put a little bit of sugar in. Okay. As I'm stirring this up, we can see that almost, yeah, so all of it has dissolved in there. So that if all of it's gone, it is unsaturated. There's none in there at all. So I mean the water is still just as clear as it was, so it's unsaturated, meaning the solution can still, the water can still dissolve more sugar. So we're going to go ahead and put a little bit more in. I think we're going to need a little bit more, Josh.
Put a whole bunch more. There, put a little bit more.
No. You don't want to over-suspend it.
You having fun there?
Yes. Okay, so now the water's pretty hazy. It looks like it's just about saturated. There's not much more sugar we can put in there. I can see a little few bits floating here and there, so it's saturated currently. Saturated is when it's full. It cannot dissolve. It cannot hold any more solution. So here we're going to show you what happens when you put too much in there. So Josh, go ahead and just pour it in. So now,
hey, that's enough.
okay. So as you can see, there's now a good amount of what we call precipitate on the bottom, which is when the solute becomes undissolvable by the solvent, and it settles on the bottom. So it's going to sit there now until more water is added, or it slowly erodes away.
Now it's time for another review with Professor Pyle.
So we've done through another 5 things right here. 5. Okay? So we had our solute, which was the sugar we mixed with the water that dissolved in there. And then we had the suspension with the Coke, Mentos, and baking soda that happened by joyful accident. And then we have the unsaturated sugar mixes when we didn't have enough in there, and it still looked like water. Then the saturated sugar mixes when it looked a little hazy and it couldn't hold anymore. The super saturated sugar mix when it couldn't hold anymore and it was too much and there was something on the bottom. But what was that something, huh? Okay, here we're going to demonstrate an endothermic reaction. This is one that absorbs heat. So we decided to bake some cookies because cakes take too long, Josh. So here, this is demonstrating endothermic reaction that absorbs heat since that the cookies are going to expand. And now, as he puts them in the oven, there's a type of heat transfer here called induction, which means the heat is transferring from the oven rack to the pan to the cookies. So hang on a second, you can zoom in here, and we'll see what's going on with the cookies. So there's your cookies in the oven, and we'll come back later while they're cooking and see what's going on.
Now you can see the cookies have absorbed heat and expanded.
They're getting yummier by the minute. Okay.
Almost done.
Almost done. Just a little bit longer.
So we're finally going to take our cookies out at the end of our endothermic reaction. That now they've absorbed all this heat. So we're going to open our oven. We've got our good golden brown cookies right here. Beautiful. These are going to be delicious to eat. Endothermic reaction and induction heating. So and also when we've been looking at these cookies right here, this isn't a physical change. Since the cookies didn't change what they are, they're still cookies. They just got cooked, or not cooked, baked. So
Baked.
now we get to eat them and you don't. So yeah.
Okay, so today we're learning about PVNRT. And because of you, Mr. Harrington, I have to say PVNRT, because apparently from what your students have told me, you don't like saying pervert, but in Holland's class we're allowed to. But for their sake, I'm going to say PVNRT. So, you're welcome. Okay, it is used to find the variable you do not know. So if you don't know what the number of moles is, you would use the rest of them to solve what the number of moles is. P is pressure, otherwise ATM. V is volume, just use your noggin. N is the number of moles. R is 0.0821. And then T is temperature, which can be converted to K.
Which is K?
What?
It's always in Kelvin.
It's always in Kelvin. It's supposed to be in Kelvin, but it could be whatever you want. No, it can't. Noggin. Cut the cord.
Cut it.
Now introducing, with another checklist, Java.
Alright kids, got my handy dandy expo marker. Alright, we had the precipitate, which was the sugar. You gotta remember that. Sugar gathered at the bottom of the supersaturated solution, or mixture as you can call it. Then we had the solution, which was the lemonade. The lemonade mixed evenly all throughout, so it was a solution, never settled at the bottom, tasted real good. Make some. Endothermic reaction, which was the cookies, because heat went into the cookies from the oven. The oven lifted the heat and went into the cookies, made them spread, and good. Then we had the induction. The induction was the heat going from the bottom of the oven through the rack, through the pan, and then into the cookies. Made them spread, made them taste real good, just like number 13. Then we had the ideal gas law. PV equals nRT. P equals pressure, V equals volume, N equals moles, R equals 0.0821, and T equals temperature. Thank you kids, you just got learned.
So today we just got one thing right here. We got the Avogadro's law, which is volume sub 1 divided by number of moles sub 1 equals the same thing on the other side, except it's sub 2, which basically means the volume divided by the moles of one thing is equal to the volume divided by the moles of another thing. So, yeah. Learn.
Alright, we got Boyle's law, which is P1 times V1 equals P2 times V2. Remember, P equals pressure, or in other words, ATM. V equals volume. That's it. Alright, I got my handy dandy expo marker, red. You got Charles' law, which is V1 divided by T1 equals V2 divided by T2. And always you list the variables, which is V equals volume and T equals temperature. Alright, you can use this if you need to find the temperature of the second substance or the first substance, or if you need to find the volume of the second substance or the first substance.
So here we got the combined gas law. This is put all the last few we've just done into one big one. So we have P1 times V1 times N1 times T1, which again is pressure, volume, pressure, temperature, volume, and number of moles. Y'all should know that by now. And it equals the same thing just like all the other ones. Now the interesting thing about this gas law, gas law, is if I took out the T on both sides, it'd still be equal. If I took out the N on both sides and left the T, it'd still be equal. You can take out you can take out any of the variables on both sides, and they'll still equal each other. Okay? So yeah, and this other gas law was also made by Avogadro. So he made 2, but this one's not named after him. So get learned.
Alright, we're almost done. Okay, so one of the last few things on this video is balancing. So what we would do to make this balanced is we would put a 2 right here in front of the H2O, which would make it H4O2. So that's not balanced. This is H2, not H4. So we have to put a 2 right here. Now this is H4, and that is balanced to that. So that's just a simple equation, so you know how balancing should work. And we had a lot of practice on it this year, so we should already know this, but it's off town, so you don't know. And yeah, get the video. Yeah, we'll just edit that out. Oh, it's still recording?
So as my partner explained, balancing is fairly simple. So now you need to know what this fancy thing is right here. Yes, it is spelled correctly. It is moles, not the thing that lives in your ground and makes the stupid holes that you trip over, mound that you trip over. You got mole equals 6.023 times 10 to the 23rd atoms. That's expanded notation. You don't know that, you need to go back to middle school. Okay, but it also equals the molar mass of all the elements in a compound, which means if you got H2O right here, hydrogen's weight, atomic mass, is 1.01. So you got 2 of them, that's 2.02. Oxygen 16, so 16 plus 2.02 equals 18.02. So that's the number of, that's 1 mole. 1 mole of H2O equals 18.02 grams. It's that easy. You need to learn this. If you don't already, you need to, because guess what? It's the end of the year and you need to be smart. So as my partner explained, balancing is fairly simple. So now you need to know what this fancy thing is right here. Yes, it is spelled correctly. It is moles, not the thing that lives in your ground and makes the stupid holes that you trip over, mound that you trip over. You got mole equals 6.023 times 10 to the 23rd atoms. That's expanded notation. You don't know that, you need to go back to middle school. Okay, but it also equals the molar mass of all the elements in a compound, which means if you got H2O right here, hydrogen's weight, atomic mass, is 1.01. So you got 2 of them, that's 2.02. Oxygen 16, so 16 plus 2.02 equals 18.02. So that's the number of, that's 1 mole. 1 mole of H2O equals 18.02 grams. It's that easy. You need to learn this. If you don't already, you need to, because guess what? It's the end of the year and you need to be smart. Here's the quiz, everybody. Have fun with this. Harrington, take a grade. Not for us, for everybody else. Thanks.
Dude. Already started it.
Yeah, can you see me?
Yeah.
Can you see you?
Yeah. Don't look at the camera. We'll just mute it. That's fine.
What do? So beautiful outside.
Unlike you.
Yeah.
Ow.